So here is a historic flood level going on right now. Here we are in 2017 on the American River. A couple terms here real quickly are a watershed and then cubic feet per second, or CFS for short. So watershed is the drainage of which all this water is spilling into these rivers. We have the North Fork of the American, the Middle Fork and the South Fork. Upstream here, both the Middle Fork and the North Fork come together. This is heading toward Sacramento. And then the South Fork's over toward Placerville. All of that rain and snow melt has been going in here into this river system in January and creating a huge volume of water. So that's CFS, cubic feet per second, and we're talking tens of thousands of gallons, cubic feet actually, of water rushing by us into the Folsom Reservoir right now. Hey, so let's talk about the river transportation and the downcutting here. So the river transportation has four terms that you would need to know in a physical geography class. The first one is traction, where it's moving these giant boulders downstream. They actually are being dragged along the bottom. Saltation is the bouncing of pebbles and sediment as it moves downstream. Then we actually have the suspended load here, which is, you can see the color here with the loaded stream. That's just sediment that's being upheld by the movement of the water and the velocity. And then finally would be dissolved load, which are like salts and other chemicals that get dissolved. So those are the four transportation modes. And this is a degrading stream in that it's definitely eroding here in the mountains, in the foothills of the Sierra Nevada, and all that material is moving into the reservoir, and in nature it would go down into the floodplains, deposit that rich alluvial soil that many of the farmers then use to create these great crops in California. So here we have it, this great flood of 2017 in Northern California on the American River. Well, let's take a look on the whiteboard about what we were seeing down on the American River during this flood stage and talk about degrading streams again. First of all, again, the watershed I talked about. Here's a nice quick map of the American River watershed, also known as a drainage. Along Interstate 80 is the North Fork. This is a tributary of the American. On just the west side of Lake Tahoe, we also have the Middle Fork coming into the confluence area. This is around Auburn, California. And we also have the South Fork, which is along Highway 50. Placerville's in there, I mentioned that, down by the river. That's just an old gold mining town here in the foothills of Northern California. So this is our watershed, and this is a top view, and it spills into a reservoir here, and then it will then spill out of it and meander into the Sacramento Valley. This would be the lower reaches that I'll talk about on a different video. But let's take a look at the upper reaches, of which where we were would count. And so first of all, we have kind of a steep gradient. Okay, so we were right on the edge of where it starts to get a little more gentle, but in the mountains we have a very steep gradient, and that tends to of course be degrading and eroding. So this high velocity, this swift water during a flood event is really going to be eroding, and that's the key characteristic of these degrading streams, is erosion. And again, that's the velocity that's really causing that. And here's some of the things that also help, though. We have turbulence, okay, so like whitewater rapids and so on. We have this hydraulic action, we've got a lot of water down there right now. Also gravity, that goes with the steep gradient. Those three combine, and you've got some swift water and some powerful actions. So that is degrading, that is eroding, and there's lots of sediment, as I showed you down by the video. Ultimately, that's going to go into the lower reaches, and we'll talk about that in a different video. There are different characteristics about that, but that's basically where all that stuff's going to get deposited. So that concludes this video on degrading streams.